Okay, now let's look at this question. Roll a failed 6-sided dice 10 times, assuming the outcome of each roll are independent. Let ace to be the sum of the 10 rolls outcome. We want to find out the expectation of ace and the variance of ace. Let's see how to solve this question. So first, the outcome of a single roll of a 6 failed dice can be 1, 2, 3, 4, 5, 6, and each outcome are equally likely because it is a failed dice. Hence, we can easily calculate the expectation of a single roll to be each outcome 1, 2, 3, 4, and 5, and 6 to be their corresponding probability, which is 1, 6. One particular outcome divided by total possible outcomes. Then we can easily calculate the expectation is 3.5. Then we can calculate the variance of a single roll. We can easily use the formula variance of x is equals to the expectation of x squared minus mu squared. So in this particular scenario, the expectation of a single row minus the expectation of a single row square is basically equals to the square of each number times the associated probability 1 over 6. So this basically is to calculate the expectation of a single row square. Is this part. And then since we already calculate the expectation of single row is 3.5, then the expectation of single row squared is 3.5 to the power of 2. Eventually, you will get the variance of a single row to 2.92. Let me clean the notes a little bit. So now, next we want to calculate the expectation of ace, which is represent the sum of the 10 rows. So we can first decompose the problem. Let ace1, ace2, ace3, and so on to denote the outcome of each 10 rows. Hence, the ace, which is represent the sum of all the outcomes of 10 rows, is equal to ace1 plus ace2 until ace10. Then we can easily use the linearity property of expectation. Expectation of ace basically is expectation of ace1 plus ace2 until ace10. So here is ace10. Here is also ace10. Then it can be break down by the expectation of ace1 plus ace2 plus expectation of ace3 plus expectation of ace10. Basically, is equal to 10 times 3.5, which is the expectation of each single row. And then we can get the expectation of ace is 35. And then similarly, we can calculate the variance. So the variance of ace basically is nothing but the variance of sum of ace1 to ace10. And since the problem given that the outcome of each row are independent, which means that we can apply the property that the variance x plus y is equals to variance of x plus variance of y. We can only apply it if x and y are independent. And in this scenario, we know that ace1, ace2, and ace10, all these 10 rows are independent with each other. Hence, we can apply this particular formula. You can think in this manner, we can treat it as x, and this is as y first. Then we can decompose it into variance of ace1 plus variance of ace2 until plus ace10. Then we can repeatedly apply the same formula, treat ace2 as x, the remaining terms as y. Then this is equal to variance of ace1 plus variance of ace2 plus variance of ace3 plus until ace10. And then we can repeatedly treat this one as x, this one as the remaining terms as y. Then eventually we can get the variance of the sum of ace1 until ace10 is equal to variance of ace1, variance of ace2, and variance of ace10. And since ace1 until ace10 is represent a toss of a coin at different times. So this is the first time we toss a dice. This is the second time we toss a dice. This is the 10th time we toss a dice. So each time we toss a dice, we have already calculated the variance of a single row actually is 2.92. Hence, the total variance is 10 times 2.92. In total is 29.2. That's the solution for this question.